and get us ready to do the modeling for next week. And when we do our modeling next week, what we're going to do is we'll take our logistic growth model and then we're going to start to modify it to add, add more than one species so they can interact with each other. And at first we're just going to worry about competition, so they'll be competing for a resource. That's what we'll start with. And then hopefully we'll get those models down. And then the next week we'll move on to predator-prey models. And so one of them will be eating the other one, right? That kind of thing. And so the models hopefully get more interesting because we're doing that type of stuff. All right. And so what we're doing today is talking about community ecology. Most of what we've done, well, everything we've done since we did physiological ecology has been population ecology. And so exponential growth and logistic growth, that was looking at one population at a time. And so essentially what we're about to do is we're going to start running 2 different species at a time, which technically puts us into community ecology. But it's not really going to feel all that much different because we're still going to be using population models to do that, right? We're going to use our logistic growth models to do it. But technically speaking, we've got more than one species interacting, so that puts us in the community ecology. I just have a little reminder on here. I could tell by when we were talking about last time, y'all are somewhat familiar with this. But if you see a little plus beside a word or a person or a group, that means that they're going to benefit by the interaction that we're talking about. A negative means they're harmed, and 0 means they're unaffected, so nothing happens to them in the interaction with the other species. I think I will quickly just remind you that intraspecific is between members of the same species. And so when we did our logistic growth models, that was what I had you, I don't remember, put a square or circle around in the model, was the part that accounted for intraspecific competition. We'll keep that because you'll still have competition between individuals of the same species, and then we're going to add now interspecific interactions, or interactions between different species. So that's what we're doing now. All right, so we can talk about predation. And so predation is considered a plus-minus interaction where one species is going to benefit while the other species, in this case, dies. So that's harmed. They don't always have to die to have a negative interaction, but in this case they do. And so the predator, it gets the positive, it's going to benefit by killing and eating the prey. So give me some of your favorite examples of predation. Mine's on here, I'll tell you about it in a minute. One of mine's on here. And then I have some slides after that. That's one of my other favorite ones.
I think of banana slugs eating other slugs.
Banana slugs eating other slugs. Banana slugs are impressive. I saw them when I was out in, where was I? Oh, Redwoods National Forest. I saw them there.
Bats and bugs.
Bats eating bugs, okay.
Chimpanzees eating monkeys. It's recreational hunting.
Yeah.
They're doing recreational hunting. I think that's cool.
Recreational hunting?
Yeah.
Not subsistence?
Nope. They'll do it whenever they have plenty of food and they need to get their energy out. They'll go eat some pork halibut monkey.
I feel like we might address some of that issue later. None of you went big though, like cheetah chasing, I don't know, an impala or.
I feel like it's pretty fair. I feel like banana slugs are just like more funny.
Yeah, you want something like that. Well, I mean that's what this is, right? This isn't a cheetah or a lion. So on this side you've got a beetle, and what this beetle does is kind of like a skunk. You know what a skunk does? It sprays a noxious fluid from its rear end. And so when you scare it, it does a headstand that you see here, and it squirts that liquid, and that generally would deter a predator from grabbing it. But this predator over here, the grasshopper mouse, understands that behavior, and what it does is it runs up super fast, grabs it, and pokes its butt into the ground so it can't get sprayed by that noxious fluid, and then he eats it. I know. So one of the things that we'll do when we do talk about predator-prey models is we'll talk about adaptations of the predator, things that they have that allow them to help capture the prey, and adaptations of the prey. What defenses do prey have against predators, right? So this would be a defense against predators, and then this is a learned behavior against that defense, essentially. This is one of my other favorite predators. You know what this one is?
Praying mantis.
Yeah, it's a praying mantis. This was taken at my previous house, although I could also do it at my current house. And it was hanging out on the railing of my back patio, deck, I guess. And I was just mostly laughing at it because it was hanging out underneath my hummingbird feeder. He's a big praying mantis, though. You can see from this picture. I didn't have a great camera. It's a big praying mantis, and I also had lots of hummingbirds. And so just below here, I had a hammock, and I'd sit in the hammock and read a book or whatever. So I did that, and then I looked up later, and you could tell it's later because it gets darker. And the praying mantis had moved to my hummingbird feeder. Now I'm getting a little alarmed. I don't really want him to eat my hummingbird, so I kept an eye on him.
Oh my gosh.
And I kept my eye on him, and you can also see how many hummingbirds I have. And I freaked out at the moment of attack, so I don't have that picture. Okay, and so it reached down and it grabbed the hummingbird underneath him. The hummingbird screamed. It was the craziest scream. It was really, really weird coming from that. And I think what happened was that the praying mantis wasn't willing to fall with the bird. And so the bird got away, and this is where the praying mantis ended up at the end of the interaction. And so I took the praying mantis and I put him in a nice little jar with some holes overnight in timeout. And then we had a discussion in the morning, and then I moved it over to the creek next to my house, hoping it wouldn't come back. And then I went inside because at this point, this is several years ago now, because I've lived in my new house 9 years, so this is 10 or more years ago that this happened. I didn't know that they ate hummingbirds, but they do, and they're an active predator on hummingbird. And after that, I began watching the area around my feeders, both before I moved and after I moved, and I have a pretty healthy population of praying mantises at both of my houses that are getting out there and grabbing them from time to time. And so here's some pictures. And then let's see if the video will work. I think birds are very fluffy, and a lot of that is illusion because they need to have a certain shape in order to be able to fly. But what they do is they use feathers to fill in that shape, and so the actual meat and organs and body of a hummingbird is much smaller than it appears. That's part of what's going on. All right, let's see if we can get it to play. Can you see what I'm doing?
Mm-hmm.
Okay, good. You can see that you can see that some of them are aware. They're looking at him. That one never saw him though. Boom. Never saw him coming. But that one over on the side is checking him out. I mean, they're definitely aware that it's a predator. Are we still in slow mo? I want to go back to fast mode real quick. There we go.
Your face that he gives them.
Why is it going slow? Are we in a slow mo?
Yeah,
we were.
I think they did that actually.
No, they did the slow mo, and that's why I won't watch it. But I wanted to go back to the fast mode real quick. There we go. Bam. All right, now over to the fast. So, that's the one that sees him. That's the one that sees him. This is the one that doesn't see him.
See, he didn't warn him that was.
That's probably a juvenile. You can see it comes up all the way to his back. Look, he grabs him from the back, pulls him down.
Did he get away?
No, I don't think that one got
You
away.
always ask.
Okay. So if you have hummingbird feeders, I also get those big flesh-colored spiders, not the yellow and black ones. And I haven't seen a hummingbird in their web, but I feel certain they could also get them. So I kind of knock them down, try to make them stay at the barn. I can't remember what they're called. They're creepy. They're big, but they're creepy, fleshy colored.
Black and yellow.
No, not the black and yellow one. No, not the garden spiders. It's the other one. I don't know.
It
I
does
didn't
sound like
notice them as much in town as I notice them where I live now. But I get a bunch of them, and they get like this big, but they're like
not
a.
work weavers, are they?
They might be. They just creep me out because they're flesh colored. They're not a pretty like the black and yellow ones are pretty.
Those ones are pink, they're bottom of the
The flesh colored ones.
Yeah,
I'm not
they're
getting
like
that color.
pink.
I'm not gonna get that close to it.
Oh, that's right. I had one for entomology and put it in the jar.
It could stay in your killing jar. There's a lot of death today. Let's talk about herbivory. Anything else y'all want to add about predation? All right, let's talk about herbivory. So herbivory is plus minus. And so in this case, the herbivore, which is the plant eater, gets a plus, and the plant that they are eating gets a minus because it's harmed by the interaction. And I think at the beginning of the semester, it's been a while now, we talked a little bit about different types of herbivores. So they can be granivores if they eat grain, they can be frugivores if they eat fruit. This is giving you a few examples here. We've got some caterpillars chowing down on a leaf. You've got a woodchuck maybe eating a stem, a grass. And then you've got the deer down there at the bottom, which are browsers, which like the woody, fresh, soft, woody browse that they like to nibble on. And so there's a lot of different things that would fall under herbivory. It's actually a very broad category. Anything that's eating a piece of a plant or so forth. And then I had you guys thinking about this last time, and that is, can herbivory ever be predation? And then I've got a hint on there if you've forgotten what we talked about on Monday. In other words, are those American goldfinches, and looks like maybe one pine siskin in that picture, are they predators in this picture? And what is their prey? The seed is their prey. So can herbivory be predation? And the answer is yes, absolutely. Because what does it take to be predation? You have to kill it. And so each seed has an embryo on the inside, and so for each seed they eat, they end that individual's potential to become a plant. So those vicious American goldfinches and pine siskins, or that cute little mouse. Mice are big seed predators. But not only are they seed predators, they're also seed dispersers. Same with both of those groups, which is a benefit to them. And what about us? Huh? Well, surely all of us eat seeds from time to time. Even if you're not a vegetarian, you should eat. If you're not eating seeds, add some to your diet. Okay? But yeah, so peanuts and peas and all of those things are representing the potential for a new life that you are ending when you eat them. That middle picture that looks like a combination of all those looks really, really good. Looks kind of like cowboy caviar. All right, this one's kind of weird. Depending on your path to this class, you may or may not have talked about this before. I don't usually address it with my freshman class, but I know some of the freshman class do. But it's an idea of amensalism. And so when you have A in biology, A means without, right? And so this kind of means without mensalism, which is weird. But this is where one species is negatively affected while the other is unaffected. So they're kind of neutral. They may not even really notice that there's a negative impact that's been going on. When I was first kind of putting slides together about these interspecific interactions, I was reading on some listservs, and there was a lot of discussion about, is there ever really true amensalism? I mean, are you really never actually interacting with the other species, essentially? And there's a few examples that they would discuss, so I have a couple of them here. We'll start with this one, since that's the first example on the list. And that is that many mammals, not just cows, but many mammals have certain paths that they take through the forest. And so they keep that path beaten down, so any grass that grows there is going to be destroyed. And so any plants that are trying to grow in that path are going to be negatively impacted, but do the cows really care? I don't know, we have to ask them, right? Probably not. That's why it's listed under this category. And then you get some chemical interactions that take place as a byproduct of going about their normal activities. And so that's what's happening in the slide over here. And so can anybody know what's happening in the slide over here? You might know what this is?
Penicillin.
Probably. Fungus is good enough. And so how do fungus feed? They release chemicals into their environment and basically do the digestion outside of their body, and then they absorb it, right? They're absorbed. We're ingesters, they're absorbers. And so the argument here, which is a little bit more complicated, and probably why people do argue about commensalism, is that all the fungus is really doing is feeding. It's just trying to digest food and absorb it. But as a byproduct of that, any bacteria in the area are killed. And so this one, they're saying, would be neutral, because it's just going about its normal activity. It's not really competing with the bacteria. It's not interacting with them. It doesn't care if it's there. They're just dying as a byproduct of their feeding activity, whereas these are being negatively impacted. Now, one of the parts of discussion is how can you really say that they're not competing with the bacteria for some type of resource? And how do you really know that it's not aware of its presence, right? That maybe some of the antibiotic properties that it have is for chemical warfare, and if that's the case, it's not commensalism. Okay. All right, y'all have any questions about that? Commensalism is just a little weird. All right, then we have the term symbiosis, which is a confusing term. It's misused a lot, and it's kind of hard to get it all situated in your head sometimes, but basically the term is a general term. Symbiosis is any type of interaction where you have a close ecological association. And the part that becomes confusing here is how do you define a close ecological association, right? That's pretty vague. But most of the time, when you're looking at a textbook, for symbiosis, they'll list three things. We'll talk about those three. Right? They list commensalism, mutualism, and parasitism as being examples of symbiosis. But you could argue that a predator-prey interaction is also pretty intimate, right? But main thing is for us to keep in mind is symbiosis is a very general term. These other terms are more specific. So most of the time, I like to watch sci-fi. So on Star Trek, they use symbiosis quite a lot. They'll talk about symbionts and all kinds of things. And most of the time, it's not necessarily misuse, it's just not specific, right? And most of the time, they're talking about parasitism, in the case of Deep Space Nine, if you're a fan. And sometimes they're talking about mutualism. But they almost always just use the word symbiosis. All right, so close ecological relationship, that's kind of hard to define, but we will go with the textbook and use the three things that are typically listed underneath there. We'll start with commensalism. The commensalism is a +0 interaction where one species benefits, but the other species is unaffected. There's lots of really cool examples of commensalism. Y'all want to give me some before I tell you my two that I like? I'll probably give you some other ones too. I like a lot of them.
Picture of a cattle egret standing on a cow.
I don't think there's any. Oh, you got one. I was trying to think what that white is, but I think it's just his spots. Weird spots on that cow. Standing on his back, the cow might not like that, but he's not picking insects off the cow. That's not what they do. And so what are the cattle egrets doing in this picture?
They're eating the insects that it's stirring up.
Yeah, so as the cows go around and move, they spook up insects, and the cattle egrets follow them and eat them. When I lived down in Mississippi, that's where I did my PhD at Mississippi State, I would be driving out to my study site at Noxubee National Wildlife Refuge. There were lots of good words down there. We lived in Oktibbeha County. That was fun. I had Oktibbeha plates on my car, so when I drive to see my parents and stuff, everybody would be like, "How do you say that?" But when they would be mowing the fields, bush hogging, I almost said in the fall, and it would happen also if they were harvesting. But even just mowing the field during the summer, you would see a tractor, and you would see like 300 cattle egrets following the tractor around. It was pretty awesome. We just don't have that many cattle egrets up here to see that. They do pass through, and you can see them in the summer, but you don't see a lot of them. I'll photograph 1 or 2 a year, not just a whole bunch. Here, when I was down there, I could photograph 1 billion a year. And so the cattle egrets are catching all the insects that the tractor's stirring up. And does the tractor care? Yeah, farmer might care. I don't know. We have to ask him. Then the other cartoon I have on here is nest building. So trees provide good structure, good protection for nests. For whatever reason, I kind of envision Dr. Greenwood as the tree here. That seems like something she would say. What is? Right, Katrina?
Yeah.
Yeah. I don't know why, but when I first saw that, that's the first thing I thought was Dr. Greenwood was the tree. And then the bird's like, I'm gonna build my nest here. But you gotta be careful, because if you're a bald eagle and you reuse your nest year after year and your nest weighs a ton, is it still commensalism? Probably not, especially if you start to have structural damage to the tree. That's no longer commensalism, right? I'll give you another example. We have those crepe myrtles over there in our parking lot across the street. Some of them have been cut out, but there's still some crepe myrtles over there. And if you look at them, right now it'd be kind of easy to see where they were. Some of them, you have the trunk, and then you have the branches coming out like this. And if you check them in the spring, they have robins that nest right there. And so the robin's nest is changing the growth pattern of that plant by the way it's placing it in the center. So would that be commensalism? Yeah, probably not. So you just have to be a little bit careful. Another one that comes up is Spanish moss. So Spanish moss, is that one commensalism? Yeah, it is, until you have so much moss that you get damage, structural damage. Don't get that confused with mistletoe, right? Mistletoe is different. Spanish moss can get, when it gets wet, if you have a lot on the tree, then it can hurt it. Right? So you gotta keep that stuff in mind. I also like the birds that follow the army ants in the tropical rainforest. Y'all heard that one before? It's very similar to this. The army ants, as they march through the tropical rainforest, everything tries to get out of the way, and they're birds that follow the army ants and catch those insects. And then as far as following the tractors around here, the thing that I like to watch following the bush hogs is the Mississippi kites. They follow the bush hogs. You get a commensalism going there. It's pretty awesome. They follow mine. When I didn't have one in my yard this year, but the previous few years I had one in my yard, and it would follow my mower. And it was pretty awesome, but I never had my camera with me. One time I'm like mowing, and it came down and grabbed an insect right in front of me, and I had to stop the mower and wait on it, but I didn't have any way to take its photo. And I'm like, nobody's gonna believe me because I can't photograph it. So that's pretty awesome. All right, now let's talk about mutualism. That was one I did mention. This is plus. Everybody benefits in mutualism. So what's your favorite mutualism?
There's, I'm probably in South America, species of tarantulas, especially like females with eggs. They'll induct a little like microhylidae frog, like a narrowmouth frog, into their little dens, and the frog will eat like any pests, like ants and stuff that are trying to like eat the tarantula's eggs, and then it gets protection from the tarantula, or with the tarantula, and the tarantula gets like free pest extermination.
Okay.
I think it's crocodiles and the birds go in their mouth.
Yeah, that's pretty funny when you say it. Which is very similar to this picture, right? I actually like this picture because I think that shrimp's really pretty. That's a cleaner shrimp. Then you have the cleaner fish too. So you have several interactions there. I usually use mutualism to talk about how to take exams. We've had 2 exams. So I don't know how helpful it is at this point. But if I say give me an example of mutualism, if you say crocodiles and birds, is that helpful? Is that really to tell me what the mutualism, what the interaction is? No. So what do we need to do?
List specific species and their interactions, like Nile crocodile, Egyptian plover.
You need to tell me how they're benefiting, right?
Or
And so in this case,
yeah,
what now?
the bird's going in there and it's cleaning the crocodile's teeth.
Right, so it gets
Bird's
food.
getting food.
And then the crocodile gets
Dental hygiene.
good dental health, yeah.
Yeah.
Which if y'all don't know is very important because the plaque from your teeth can go and get into the valves of your heart and kill you. I know, right?
The reason why I asked about ants in like the first picture with the ladybug and stuff is because ants will also like farm colonies of aphids for honeydew, and then they'll also protect the aphids from ladybugs trying to eat.
Yeah, I don't think that houseplant is doing that. But if you do have house plants that have aphids on them, mix up a little bit of soap and some water and spray it on your plant, and they'll take care of it.
The woolly alder.
I had that problem one time.
That are like on the sourwood trees near Pacer Pond. They'll have like ants all around the garden.
Before I got another one on the next slide, but one of my other favorite ones is there's a woodpecker that excavates its cavity in hornets' nests, which is going to keep it safe. And then I'm not real sure in that case what the hornet gets. Maybe that's not mutualism now I'm thinking about it. But I feel like in the video it said it was mutualism. All right, anyway, here's another one of my favorite ones that I like to talk about. This one's a red-billed oxpecker, which is just a great name. The freshmen love this one. They just like to giggle. I don't know if they really love it, but they like to giggle. There's two species of oxpeckers in Africa. There's a yellow-billed, which is the one I got to see when I was there, and then there's the red-billed. So these are red-billed oxpeckers. And you see them clinging to like every animal that can have a parasite on it. That's pretty broad. So you would see them like if a hippo puts its head up out of the water, you'll see one like on top of the hippo's head. You'll see them on the giraffes. You'll see them on all of the ungulates. And what they're doing is they're picking off the parasites. And so it benefits by getting food, and then the animal benefits from getting reduced parasite load. And so I always point out to them in the second picture, those aren't berries in that oxpecker's mouth. Those are big, plump ticks full of blood. And blood is an excellent food source, lots of nutrition for the oxpeckers. I also like to use the oxpeckers though, because when I was in Africa, the guide was talking to us about them. And he had kind of a negative connotation from them because they would come and they would pick parasites off their cattle, which is not, that part's not bad. But if the cattle had an open wound of any type, the oxpeckers peck at the wound and lap up the blood, and they'll keep the wounds open, which leaves them susceptible to infection. And so it goes from being mutualism to something else again when they're doing that, right? It's no longer mutualism if they're doing that. And so in that way, they can be a little bit of a pest, especially if you want a healthy cattle for whatever for your benefit. It was kind of interesting. I talked to our guide. We had two guides on that trip. We were in Botswana, which is just north of South Africa, and the company we were with was South African. And so we had a South African guide, and he was just a typical guide. But then in Botswana, we picked up a local guide, and he was a local Botswanan, and I talked to him quite a lot. And at the end of the day, I'd often ask him questions about his view on the wildlife, because it's got to be weird. So we went out and we saw hyenas, and we saw hyenas with puppies, and it was awesome, right? And we're all like, that kind of thing, eating it up. And that night I asked him how he felt about hyenas, because I knew they could be a nuisance, and I knew that he had cattle, and yeah, he hates them, right? It's something that he has to constantly deal with as part of his life. And then his other job is taking us out, and we're all like, ooh, cool, look at that, yay! It's just got to be weird. All right, parasitism. So parasitism is plus minus, and so the parasite benefits as it consumes relatively small amounts of tissue and fluids from its host, which is going to be negatively impacted. But why does this definition specifically say relatively small amounts?
Because you're not like killing the host.
Yeah, that's where they live. Yeah, so they don't want to kill their host. They want to live in a close ecological relationship with them, right? And so that is not their goal. It is not their goal to kill them, but they do have an impact on their overall health. And we kind of talked about disease when we discussed sexual selection. Parasites are a big driver as well. And so the parasite load that an animal carries has a lot to do with its health and ability to survive. I saw a presentation at a conference a few years ago about waterfowl migration, and what they were looking at was the parasite load and kind of success of the migration. And those that had higher parasite loads were not able to migrate as quickly and as effectively or survive than those that did have a lower parasite load. But one of the things they really wanted to get across was that all of them had parasites. That's a normal part of their flora and fauna, because in our society, having parasites is viewed as bad. But At the same time, we talk a lot about having a healthy flora and fauna, and the big emphasis on making sure our microflora in our gut, for example, is healthy now. But those are mutualistic, parasitic, all those types of relationships taking place. They're natural and normal was a big point of that presentation, along with what they found. So this one is a tick. It kind of grosses people out, but I like to show them why it's important to get the head. I freaked out last summer because I just pulled the ticks off. I pulled one off my dog and I didn't get the head. I think that was the first time that ever happened, that I didn't get down there deep enough and didn't get the head. He must have been buried like this. And then I was like, oh my gosh, what am I gonna do? And then I looked online and they're like, it's not a big deal. It can be if there's a disease, I guess, associated with it. But as far as the head itself being embedded, your body will push it out. So it's kind of funny. The other one is a what?
The lamprey.
Yep, those are lamprey, suction cup to the side of the fish. Both of those are on the outside of the body, and so they are ectoparasites. Now, some of you have had orno, so you already know what's happening in this picture. My most intimate interaction with parasites. Whoa.
Those are your favorite.
Or not like them.
When we were catching rats over the summer, we'd have to pull the parasites off and put them like in little things. Some of them, like little bat bugs, were actually so fast, and then you would like miss where they went, and be like, okay, well, I can't find it now. And like 2 minutes later, you'd see it on you. Oh, worst feeling ever.
You pretty much described the story I'm about to tell you.
Yeah,
Except birds.
They're pretty big for being on bats, but they're still pretty big.
Yeah, it's
size
this.
of a
It's
regular
that same
tick.
thing probably as what you got right there,
Okay.
or very similar to it. So this is a bird. It's a weird picture, but the eye at the top, and then that's it's the elbow of the wing, but the bend of the wing there. And then that's a louse fly. And there are louse flies that live on mammals and louse flies that live on birds. They are basically squished houseflies. They look like dorsoventrally flattened, if you want to be scientific, houseflies. And they run around underneath the fur and underneath the feathers. And so I had a student who hit a great horned owl, I believe it was, and she called. It's actually Gina Lowry out at Paris Landing, if you know this park ranger out there, that's who called. And usually if somebody calls me with a bird, I'm going to say yes, because I want them to call me again if they get a different bird. So even if it's something common, I'll usually try to meet them or have them drop it off in the hopes that if they do have something uncommon, they'll call us. And so she said it was freshly hit. Her and RT, her husband, had nudged it. They saw it in their headlights and they slowed down, but then it flew up and hit the grill. And I was like, okay, we'll bring it in. And it had never been in the fridge or freezer, and it was just in a box, and they brought it to the biology department. And I was free that afternoon, and I thought, well, it's pretty easy to skin fresh birds, a lot easier than if they have freezer burns, so I'm just gonna go ahead and stuff it. All right, so I got it and took it downstairs. Most of you are familiar with that room. You've got the laboratory where you have class, and then you have the museum behind it. So Dr. Blanchard had class. I don't remember whether it was Acre Hurt, but they were in there looking at their wet specimens, and I was sitting in the museum. Got everything in order, put the bird out. It was good and flimsy. Wasn't really that warm anymore, but it wasn't actually cold either, so kind of in between. And so I parted the feathers. I took my razor blade and I made an incision, and right as I made the incision, one of those ran across my hand. And because of the timing, I wasn't sure whether it came from inside the bird or outside the bird, and that really freaked me out badly. And so I went screaming through the classroom and everybody laughed. And I went upstairs and I got Dr. Pitts, the entomologist, and I said, what the heck just happened? He said, well, it sounds like a lousefly, and he got excited because they don't get a lot of bird parasites in entomology. And so he came downstairs and he put his hand on the bird, and pretty sure soon one of them just ran right across his hand. And he was like, yeah, and put it into a little tube. And he sat there for a while, and the more he sat there, not only did he have louse flies running across, but you started to get some mites and some other things, fleas, other things hopping around on his arm. And he was explaining what makes perfect sense. I'm just not a parasite person, so I never thought about it. And that is that the parasites are moving onto him because he's warm, and the bird is losing its body heat, so they're aware that it's dead. And so I said, have fun. And I left. And he put the bird in the freezer, and it stayed in the freezer for a couple of weeks before it was later stuffed when all the parasites were dead. And so that was pretty gross. But those are ectoparasites for the most part. I was relieved to know it didn't come from the inside. I was telling Gina about it later, and she didn't tell me the whole story on the phone. So the story on the phone was it looked kind of sick, but she didn't tell me that when they walked up to it that there was a swarm of flies around it. And so it had a very obvious high parasite load, which is probably why it wasn't doing well, because she said it was kind of walking funny and then it flew up into the grill. And she said they didn't hit it hard enough for it to die necessarily, so it was already a sick bird. All right, if they live inside the body, that's an endoparasite. So this one's a tapeworm, probably a canine one. Can you think of other endoparasites?
Heartworms.
Heartworms. Heartworms is a type of roundworm. So there's heartworms. They kind of get separated out in the vet because it's different treatments, right? The heartworms are roundworms, but they're in the heart. But you can also have roundworms in the digestive tract. And then you can have horse dogs, and cats. You can have the tapeworms.
Flukes.
Huh?
Flukes.
Flukes. Yep. Schistosoma. I can't say it. Yep. And then things like bacteria, viruses. Those are also parasites, actually endoparasites. So the life cycles on the endoparasites are often quite complicated, like the flukes. They'll have what's called an intermediate host. And so the schistosoma, which I'm having trouble saying, its intermediate host is a snail.
Is it the one that like infects the eye stalks?
I don't know. I just know the snail's intermediate host. And then if you're walking around barefoot in the water, they burrow in through your skin and get into your bloodstream. And then they reproduce, and the little worms clog your blood vessels. Or not worms, flukes.
I was gonna share it because it's gross, but it's with birds, because there's like a fluke where I wouldn't be able to say what kind of host it is, but they rely on birds for part of their life cycle.
I'm
And
sure
so
there's
what
lots of them.
they do is they get into the snail and they get into its eye stalks and they start like making all these like pulsating colors and waves to get birds to come down and attack the eyes of the snail and then eat the flatworm.
Sounds like a thing.
So
I had a puppy, not my current puppy, and when I got her, she had the worm belly, the swollen belly. Swollen belly. And so she was only 4 weeks old though, so I was just kind of asking the vet. I was asking my dog, who was 4 weeks old and weighed 2.5 pounds. I was asking the vet, where did she get them? Because she said she had tapeworms and roundworms. And the tapeworm in particular, she said, probably from a flea. That most of the tapeworms around that was in central Mississippi, but I think it's pretty much the same here, use fleas as intermediate host, and so it was probably nursing on the mother, and then the mother was, covered in fleas and accidentally swallowed the flea, and that's how she got infected. But my cat had tapeworms this summer, and when I went to pick up the medicine for the cat and dog, poor dog, because don't even know if she had tapeworms. But she's in the house with an infected cat, so she got to also take the medicine. I asked where the cat probably picked it up, and they said fleas again, either fleas or infected meat. We hadn't had fleas on either one of the pets in the house, and so it's probably that she grabbed and ate a mouse, picked it up that way. So it's kind of interesting.
Or there's a parasite that cats can pick up by eating feces.
Yeah, she probably does. I hope she doesn't get it. I hope she doesn't. I think she ate a baby mouse, because the big mice she leaves, and then she caught several lizards this summer, and she didn't eat the lizards. So, but I found like a patch of baby mice that were dead. I think she might have ate one. Anyway, fun times. All right, then you get this weird interaction called parasitoidism. You can ask Nala. Here's what happened. For the cat, I don't know if y'all have cats and dogs, but for the cat, for her tapeworm treatment, she just got a few drops of medicine on the back of her neck. For the dog, I had to take a giant syringe, shove it down her throat, and then, I don't remember, 3 weeks later, do it again. Poor dog. Anyway, so parasitoidism isn't kind of your classic example. It wasn't on the slide where I was talking about the different types of symbiosis. It's really weird stuff, and so it's somewhere between parasitism and predation. And so a lot of times, and we're going to watch 2 videos, A lot of times in the videos, they're going to refer to the parasitoid as the parasite because it is going to live off of the fluids of the organism that it's infecting. But at the end of the interaction, the individual is dead. All right, so that's why I'm like, it's somewhere in the in-between. It's in that gray area where a lot of biology sits, where it's harder to classify into one thing or another. So this is a hornworm. It's a type of caterpillar. And then those eggs on there is from a parasitic wasp. So that's one of the videos we're going to watch. But I think the first video is going to be, I got the wrong kind of fungus stuck in my head.
Is it cordyceps?
Yes, cordyceps. I had chytrid, and I know that's wrong. Whoops. Don't look at all those formulas. Those are for Monday. Whoops. Hopefully I picked it up.
Incredibly, 80% of all insects live in jungles. Few are more successful than the ants. There can be 8 million individuals in a single hectare. But jungle ants don't have it all their own way. These bullet ants are showing some worrying symptoms. Spores from a parasitic fungus called cordyceps have infiltrated their bodies and their minds.
Trying to turn the lights on, it didn't work.
Its infected brain directs this ant upwards. Then, utterly disorientated, it grips a stem with its mandibles. Those afflicted that are discovered by the workers are quickly taken away and dumped far away from the
I
colony.
think you're just gonna have to stand there.
It seems extreme, but this is the reason why. Like something out of science fiction, the fruiting body of the cordyceps erupts from the ant's head. It can take 3 weeks to grow, and when finished, the deadly spores will burst from its tip. Then, any ant in the vicinity will be in serious risk of death. The fungus is so virulent, it can wipe out whole colonies of ants. And it's not just ants that fall victim to this killer. There are literally thousands of different types of cordyceps fungi, and remarkably, each specializes on just one species. These attacks do have a positive effect on the jungle's diversity, since parasites like these stop any one group of animal getting the upper hand. The more numerous a species becomes, the more likely it will be attacked by its nemesis, a cordyceps fungus.
Sephora is everywhere you are, so when you need a gift,
Okay, so any takeaways from that video while I pull up the other one?
I just think it's really. Is it still? I don't know if like the fungus, like consume. I mean, it probably does, and I can't really think of any other examples where like the parasitoid doesn't like consume any part of the host. But even in that sense, like the reason that the fungus does it is like mainly to like spread its spores, like to.
Right, but it eats the host.
Okay, so it's still
Yeah.
considered like somewhat predation.
Well, I mean, it ends up dead.
Yeah.
Right? That's why I said it's in the gray area, right?
I guess
A
what I-
parasitoid almost
right.
always ends up dead, or not the parasitoid part, but the one that's the host is almost
Right.
always ends up dead. But yeah, those pictures of the dead insects there were consumed by the fungus. I think for both the video that we just watched and for the video we're about to watch, which is a little grosser, by the way, what interests me is the zombie aspect, right? That is, the cordyceps fungi is known as the zombie fungus because it changes the behavior of the animal that's infected. And so in the case of this video, it changed the behavior of the ants and caused them to move towards the light instead of towards darkness. And that's part of what triggered the ants to know there was something wrong with it, right? Because its behavior changed. And you're going to see that again in this video. This video is going to be the parasitoid wasps, which is your pretty classic example of parasitoidism. But there's going to be one point in which they burst out. That's the grossest point. So if you can't hack it, I guess, close your eyes for a minute. But it's not that bad.
It's the same video we did.
Oh, I forgot to put it in there. You're right. I forgot to do that.
Or you want to try something new.
You are correct. There we go.
Parasitized cat has spent the last 12 days gorging itself. It now appears profoundly obese. But this
That's me after
is
Christmas.
not all fat. The glomerata wasp larvae lie just under its skin.
I'm already grossed out.
No, look, it's fine. I gave you a warning.
Is the size of a grain of rice, but together they
Just
account
listen to the
for
story.
over a third of the caterpillar's weight.
It's actually
The
amazing.
larvae have not
This
yet
part.
finished growing
Well,
and need to keep their host alive.
we've already said it.
So although they feast on the caterpillar's blood, they have been careful not to touch a single one of its vital organs.
It's pretty amazing.
This uneasy truce will not last. Within days, the larvae are fully matured. Suddenly, they begin to stir into action. For the past 2 weeks, this surrogate womb has protected them, but now they no longer need it. To complete the next stage of their life cycle, they must break out.
That's the gross part, just FYI. Have to get to the outside world.
The caterpillar's thick skin should be a solid barrier to the parasitic wasp larvae. But as their bodies have grown, they have developed tiny, saw-like teeth. These jagged jaws are for one job only: cutting their way out. Stroke by stroke, the larvae slice through the tough layers of skin. At the same time, they release chemicals that paralyze the caterpillar. As the larvae break through, there is nothing it can do.
I told you, when they break out.
Free at last, the larvae enter a new phase of development. They swiftly spin silken cocoons. These will provide the perfect environment for their final transformation. But ironically, one of the greatest dangers the larvae will face is being themselves impregnated by other species of parasitic wasp. Incredibly, the wounded caterpillar helps them out. Eventually, a caterpillar would spin a silken blanket to make its own cocoon. But the parasitized caterpillar spins his blanket on top of the wasp cocoons, giving them an extra layer of protection. Scientists believe the same wasp virus that infected it weeks before has now invaded the caterpillar's brain and caused this bizarre corruption of its normal behavior. Amazingly, the caterpillar's natural aggression is now also exploited by the wasp virus. The caterpillar becomes a bodyguard, actively protecting the cocoons from other parasites. It will watch over them unceasingly until it eventually starves to death.
Fried chicken and wonton.
All right, what are we looking from that one?
teriyaki glaze and an egg roll.
Automatic caterpillar.
What now?
Automatic caterpillar.
Yeah, right? Whoops, we don't need to go to my email. Yeah, there are so many bizarre parasitoid stories. This one has that same element of a corruption of the behavior, right? That to me is the most interesting part of the video. The rest is pretty standard parasitoid stuff. And that is that it not only survived all of them breaking out of its body, because it had wounds all along its side, it spun its cocoon around them and then protected them. I mean, that's just crazy manipulation. It's hard to figure out how all that kind of works together. I think it's interesting that they suggest that this is not going to be your best source of current factual scientific information from Nat Geo. But it's interesting that they suggested it was a virus that was responsible for doing that. You would want to look more into see if that's really the case or not. All right, anything else about parasitoidism before we go on?
I'm kind of curious when they injected that paralyzed
Paralyzed.
the caterpillar from the beginning, and then maybe that was part of the effect of turning its brain to cocooning them afterwards as well.
You would think we don't understand. The brain is like the one thing we really, really don't understand. Like if you take neurobiology with Dr. Gather, she'll talk more about that. But I would say that's possible. However, this is targeted, right? It's not affecting the whole brain. It's not affecting its autonomic systems, automatic systems, because it survived all of that. And so it's targeting something specific. So I don't know. That's about as much as I can tell you about it. But our own brains are like that. We talked about this a little bit when we discussed light sensitivity in animals. That one of the ways we know is because we destroy different parts of the brain and see what happened, right? But in humans, we can only do that if somebody has an injury and that affects their behavior, essentially. I don't know. It's complicated. So somebody y'all can study it. It's a good thing to go out and study. Understanding consciousness is like a huge field. People are really obsessed with that at the moment. Like, when do you make a conscious decision? And the argument is most of the decisions that you make are made before you're aware of them, which is kind of freaky to think about. All right, then we have interspecific competition. This one can confuse people sometimes because it's minus. Both species suffer. And usually they're competing because they're after the same resource, whatever that resource might be. Now, when you originally think about interspecific competition, the classic picture that you'd have up here, if you're like in my freshman class, I'd have a classic picture of a carcass in the Serengeti, and on the carcass you had a lion, and then behind the lion you would have vultures and hyenas, right? And so in that particular case, you have a clear winner, which is the lion, and you have these others that have to wait until the lion's done feeding before they're able to get food. However, even though the lion is a clear winner in that particular case, the hyenas in particular, and the vultures to some extent, are going to constantly harass the lion, right? They'll come up, they'll try to grab a piece when it's not looking, they'll try to tug it away from the lion if they're bold enough. And the hyenas, if they have enough numbers, will try to pull it away from the lion. And so even though the lion generally is going to win, it's generally going to get enough to eat, it still has to expend at least some energy trying to defend its kill, right? Even though the others might have to expend more energy. So that's uneven. We're going to talk about the actual kinds on Wednesday. The picture that I chose is an indirect interaction because I feel like we're in a senior level ecology class. We should be able to comprehend these things. And so the resource in question here are acorns. And there are two species around here. There are probably others as well, of course, squirrels and things, but two species in particular, the white-tailed deer and the turkey that like to eat them. And I moved the picture, and now I'm unhappy that I moved it. It's okay. On the next slide, I moved the picture. And so what you get here is I have seen, that's the picture, I'm going to go ahead and bring up the pictures. I have seen, there we go, turkeys and deer mixing up here. This is just right next to my house. With turkey and deer, it's not uncommon this time of year to see that happening when the acorns are falling. The acorn, I'm just wondering how many acorns are on the tree that sits above the roof of my house because I feel like it's already dropped 1 billion. Anybody else have an acorn tree, an oak tree above their house? Oh my gosh. I switched from a metal roof to an asphalt shingle roof last year, but it's still pretty low.
What gets me is the squirrels running across
Yes.
the house getting all the acorns.
I have it upstairs, and I got Scout the cat specifically because I don't go upstairs a lot, and she goes up there and hunts, and that's her purpose, right? That's why I got her. But they were running out on the roof so much, I got paranoid that they were in the house running around. Oh gosh. Anyway, that's beside the point. This picture I took at Lamb Twin Lakes, actually, at the Elk Bison Prairie, where you have the elk and the turkeys in there at the same time interacting with each other. So that happens as well. My point in this case is I've never, not that it wouldn't happen, I guess, per se, but I've never seen a deer kick a turkey. And I've never seen the turkey like fly up and get on the back of the deer and ride it out away or anything. So they aren't actively interacting with each other. However, by the deer consuming acorns, that's reducing the amount of acorns available for the turkeys, and by the turkeys consuming acorns, that reduces the amount that's available for the deer. And so while they are not physically interacting with each other, this is still interspecific competition because they are using the same resource. Does that make sense? All right. And so as we go forward, we're going to continue to talk about competition. That's going to be our goal, is to build what are called Lodka-Volterra competition models. That's what we're going to start building on Monday and finish up on Wednesday, hopefully. And the competition that we're talking about may be where they fight, where there's physical interference, but it may also be that one of them's using resources that the other one needs. And that's going to impact their population size, right? So if we just had turkeys and they had all the acorns, you could have X number of turkeys. Now if we add deer into the situation and both the deer and the turkey are eating acorns, how many turkey can we have? Less. Right, exactly. Less than if we didn't have both of them eating the acorns. That's the point. So they are impacting each other's population in that way. And we could go the opposite way, of course. We could remove the turkeys and see how many deer we'd have, and then put the turkeys back and watch the deer population go back down. All right. So even though they don't kick at each other or anything, they are still competing. Alrighty. That was where I thought I would stop today. We're going to talk next about 2 types of interspecific competition, and then that's going to lead us into our models, our Lodka-Volterra competition models. But we will do that on Monday, and what I hope to do is to get the bulk of the model out of the way on Monday, the assumptions of the model on Monday, so